Number 3, what do we want? We want the formula of the hydrate. So we have this salt with an unknown number of water molecules attached. When they dried it out, they heated it to a constant mass. They heated it and heated it and heated it until it stopped losing mass. That means all the water is gone. 25% of the mass was gone then, so 25% of the mass was from water. So what's the formula of the hydrate? Well, let's just sort of throw some numbers at it. What if this had 1 water? Then if the molar mass is this, let's pretend we had 1 mole because it won't matter. We can pick any amount we want. 1 mole of this would be that mass, and 1 water would be that mass for a total of this. And then the water by percentage would be 18 over 121, which is kind of 18 over 120, which is kind of 10%. It's a little low, but it doesn't matter because it sure isn't 25. So let's try to have 2 waters, in which case the mass of the water is 36 for 2 moles, and there's 1 mole of the original. Now we have 147.1, and the mass of the water is 36 over 147.1. Now that sounds a lot more promising. Let's prove a point. I did it 2 different ways mathematically, one trickier than the other. So I want this to be 1/4 of that. Is it 1/4 of that? Well, you can get out long division and stuff if you want. Remember, you don't get a calculator. So I'm going to say, what's 1/4 of 147.1? And I'm going to scoot the decimal over here mentally. And I'm going to say, let's call this 14 over 4. Because I want to get 25%, and that's 1/4. 14 over 4 is 3 2/4, or 3.5. But remember, I cheated the decimal down 1 spot, so it's not 3.5, it's 35. To put the decimal back where it belonged. Because remember, I was 10 times too low, so this is really 35. Now, I ignored the 7.1, so it's not 35. It's a little bit more than that. And you know what? It's probably about 36. And then I cheated and I got out the calculator. It's 36.2. Look, yeah, it's really close. And since we can't have half a molecule of water, that's it. It must be 2 molecules of water. Well, in case you're interested, I also got a little bit more math tricky. And I did it this way. I'm going to scoot the decimal this way, divide by 10. And when I multiply by 0.25, I'm going to scoot the decimal that way. So on this number, I've divided by 10. And on that number, I've multiplied by 10. And you can do that mathematically legally if you're multiplying or dividing, not when you're adding. If you're multiplying and dividing, you can multiply one part by 10 if you divide the other part by 10. So that's what I did. I divided by 10 and then I multiplied by 10. And then I broke up my 2.5. Now my 25%, my 0.25, is 2.5, except I broke it up like this and I just took the 2. 2.5 of something means let's have 2 of them. That's this. And then let's have a half of it. So half of that is more or less this. So I have 2 of that and a half of that, and that's this. And look, I get basically the same answer. And since you can't have half or a quarter or whatever, or any fraction of a water molecule, it has to be a whole. There you go. Is 36 1/4 of 147.1? Yeah, it is. So your formula is 2 H2Os are used. 25% of 147.1 is roughly 36, so you used 2 waters. What's the empirical formula? It's the simplest whole number ratio of a chemical formula. Number 5 isn't really even worthy of our time, except to say, remember, a centimeter cubed is a milliliter. They are literally the same things. They couldn't be more of the same. I'm not saying they're kind of the same. I'm saying they're the same thing. I'm not saying like Don and Donald are the same person. Right? It's the same thing. So if you use this on the top to get the grams to cancel out, really what you get is, well, it's not even really. You get milliliters, or you call it centimeters cubed. They can't argue with either answer. They are the same name. They are different names for the same thing. Where does this absorbance graph absorb the best? About here. And you know what? That distance I'm betting is about that distance, which means this is 400 nanometers. Best is 400, and worst would be about 500 nanometers. picture depicts 8 particles of XY, 4 of X plus, and 4Y minus floating in solution. What do we know about the solubility? Well, if you had 8 solid, right, and you have 4 of these dissolved, you must have had 4 of these that dissolved. 8 of them didn't dissolve, and 4 of them did. So 4 out of the 12 dissolved, and that means that it dissolves at a rate of about 33%.